Hello viewers, welcome to our Java multithreading series, and I think this is the very first topic where I want you to get comfortable with using threads. Although the topic name is thread life cycles, but we'll be looking everything in a very nutshell for you to get comfortable if you are already into learning Java and you are considering threads in your roadmap, learning roadmap I should say. So this is Abhyuday Shukla and let's begin the session. Before proceeding for thread life cycles or anything like that, I would just take you through some very basic Java code that I've created for you to get comfortable and onboard yourself into the usage of threads. So we'll begin our understandings with observations. Now, here is a small code that I've created. That's the name of the class, that is counter demo threads. And in this class I have created two threads. Okay, when I say I have created two threads, it may look like I've created two instances of class objects, but I'm calling it threads because they are both extending thread class. So as I go into increase counter, this class extends thread class and also override its run method. So it is essential for a class that extends thread class to add its run method. That's what a thread is going to do when it comes into action or execution. Now, as the name suggests, for the class, it is just an increasing counter. It counts from 0 to 5, and every time it counts, it just prints. And with every iteration, it takes a 2-second sleep. That is 2000 millisecond and 2 seconds of sleep on the clock. Another class opposite to this is the decrease counter. It does the opposite work. It goes from 5 to 1. Okay, every time it prints, it goes like decreases the value by 1, and every time it prints, every time it iterates, it takes a sleep. I should say this is a nap for 500 milliseconds. That is half of a second on the clock. So we'll just go by executing this. Now, very first observations that we can make over here are program started should be printed right at the first. Yes, it is obviously there. But immediately we can see that program finished got printed despite the program, that is the main, was executing. Now here I want you to understand something about threads. The one which we see over here is called the main thread. Now main thread is always a default thread for other threads, or I should say the parent thread, which we are anyway going to come to in shortly in the thread metadata thing. But we have to understand, like, once both the threads were in action, that is when we called their start method, they all, like, both of them got into action. They started executing whatever was described over there, run. Okay, run method. So they started working, but the main again was independent to work, complete its own work, and it did. It completed the program. It just printed the program finished. So from here it created both the threads, both the threads got it working, and the main came into this particular statement. And because of this, we are observing two statements right together. Had this been a sequence like a normal code, it would have been like the program finish would have been printed right at the last of this particular output. Now, for once you can see that decrease counter starts from 5, it takes a small pause of half a second, that is we defined 500 millisecond right here. And as it relinquishes the CPU, as it's going to sleep, increase counter comes into action and does its work. Now however, for every iteration increase counter, it again goes into a 2-second sleep, and meanwhile the CPU is free. And meanwhile it's pretty much time for decrease counter to get into action, do its work, and again go to sleep immediately. And as decrease counter sleeps, it's again time for increase counter to come into action. That is the wake up. It's 2 second, that is 2000 millisecond waiting time, is sleeping time is done. So that's why some way you can see decrease counter executes, and then increase counter, and then decrease counter executes for a bit, and then increase counter comes into action. The decrease counter, when it comes to 1, is actually done with all its work, so it doesn't come into action anymore. And increase counter basically does its own work until the work is finished, and then we have process finished with exit code. Now, few things that we can do over here is we can just make use of join method for waiting for increase counter to finish, and only then program, that is the main thread, should be finishing. So if we just add increase counter dot join here, we are actually instructing JVM to wait for the main thread to complete until we don't complete the increase counter. So this is somewhat will give us understanding, like will give us an output like the program finished will be printed right at the last. So I'll just quickly execute this code after adding the increase counter to join. So program started, yes, it should come at the first. Okay, now we can see decrease counter completed its work, but the increase counter is still working, and as increase counter completed, only then the program finished got printed. That is the main thread got into action, because we had already added increase counter dot join, and we were about, like, we were telling the JVM to wait for the increase counter to complete, only then the main thread should continue from there. The other way, if we add this to decreasing counter like this, it would become like decrease counter dot join, and we are instructing the JVM to wait for decrease counter to finish, which finishes slightly before the increase counter does. So we will observe the program finished, this particular phrase be written just after the decrease counter 1 is achieved, as this decrease counter completed its work. So I'm talking in very simplistic terms for just for you to understand, nothing fancy and technical right here, because here we are just onboarding and getting used to the observations that we are understanding here. So as discussed, right, the program finished that we can see here, as the decrease counter ended, the main took the show, and the increase counter kept working as it wanted to. So these are some very basic observations that I can say we have. Okay, now also I would like to take you through various statuses of the thread, but before that, let's discuss those. For thread states, right, I have created separate class, which one of them is multiplication thread, which again extends thread, but it prints a lot of data, the metadata about the thread. I will take you through each of these statements, but the driver class, I should say, is thread states for this one, and I've added pretty much like most of these you can say the loggers to understand the status of the thread that we are currently in. So first we'll discuss what threads are, okay, what the threads life cycle are, and whatsoever like goes through what statuses a thread has. So first of all, we have a new state for every thread that is not called for the start method assigned to it. So unless we call the start method, miss the spelling, but that's fine, there's a typo. Then we call the thread as active when we essentially mark a call to start method associated to it. So when I call this particular method, it's the thread that gets into the active state. Now after this, we have active itself is not a defined state in Java. A thread may not be executed immediately as we call the start methods, but it may be ready to execute with all the resources in place. So we call it as runnable. Okay, but when it is actually running within the CPU is attending that particular thread whatsoever it wants to do, it is called the running. In some way we can say the program under execution is called a process. That's a very basic definition, but still thread and processes are very different. Okay, now a thread could be in a blocked or waiting state. The term is used interchangeably. It could be called blocked when it's waiting for some other resource, or like waiting for when it is being waiting for another thread to complete. So in our current code, right, we saw that the thread was actually waiting for other thread to complete, the main thread. Let's open this example yet again. So the main thread was waiting for decrease counter dot to complete, and only then it printed its rest of the work. So that's why it's called blocked and waiting state. Terminated when a thread has finished its task or whatsoever we assigned to. So it might be that when decrease counter would be called as terminated when the program finished showed up over here. We'll understand metadata of the thread and the statuses of the thread through this example that I just told you. So I've created a class that extend thread class, that is multiplication thread. It doesn't do anything as such multiplication. I just wanted to be new with the names so that we avoid confusion, but it just prints the numbers from 1 to 4 and like 0 to 4 it should be. So it's just usual yada yada. And here we are mostly interested to understand the metadata associated with the thread and the statuses of the thread. So first I'll take you through the execution itself, how it works. So let me run this code. Okay, now meanwhile the code is running, we are all set to go through the explanation of this. So currently when we see like before, as we created the instance of that particular thread class, right, and do make a note of, we hold the reference of thread and the instance is actually of multiplication thread class itself. Now we can do this because we are extending thread class anyway. So thread state, which got printed right over here, currently it's new as discussed over our first statuses. When the thread is in this state, unless we call its start method. Okay, so we haven't called the start method yet, and that's why if we call the thread dot get state, it printed new. And as we called the start method, it went active. Okay, so we went into active. Active is not essentially a state that is defined in Java language. We just call it thread. Runnable is basically the one which we can call. And as we call the start method, the thread should essentially hop over to its run method and execute everything. So current thread name is something that got printed right here. Now this current thread name, unless we give the thread a name, okay, like here I can give thread a name, then I can execute this program again and it will be like YouTube demo thread, current thread name. So this is what that got printed over here. Thread.current thread and get name, where thread is the class that can get the stat with the static methods, and it can help us know all the essential things of that particular thread that we are into. So into the current thread we are trying to get the name. So that's why we got the one which we already had set, which is YouTube demo thread. The current thread ID, it is given by JVM. We should not be tinkering around this when we are very new to threads. And the thread group, now here it gets a bit tricky. Okay, now to which thread group a thread belongs to. You can house threads within different thread groups, where thread groups itself is type of a class. Now here, since the JVM has created, like we have created this with a very basic set of example, the default thread group is called main. And along with this you can see the max PRI, which stands for max priority, within this particular thread group is 10. We'll come to thread priorities a bit later, but the maximum priority within this particular thread group is 10. That is the highest priority in some way we can say. Now if we want to hop over and understand what is the parent of the current thread, we will see the parent of the current thread is the system. It means although like the current thread group and the parent of the threads are different. So we currently got the thread group which is called, okay, I should rather just add one more thing. Will that work? No, that won't work. So yeah, so currently the parent of a particular thread group, that is this particular thread, what we call as YouTube demo thread, is in the main thread group, And who is the parent of that particular thread group? It is the system, which we can sometimes refer to as operating system. And who is the grandparent of that particular thread group? So think this should go like get parent and then get parent, it should be. So I'll just execute this code again and let's see what comes again. So after system there is no parent, okay? It's the operating system till which the thread parents last. So the all ultimately the great grandparent or whatever you can say is basically null. After system there are no parents, okay? And within the system itself the max priority a thread can get is 10. Now we'll skip these parent and non-parent, it may get overwhelming sometimes, but I just wanted you to understand that there is something called like hierarchy and we can understand what are thread groups later. So current thread priority. Now what is the priority of the thread? Since we haven't added any priority to a thread, the default that JVM gives any thread is 5. Okay, so priorities range from 1 to 10, which anyway we will come to a bit later, but that's fine, like 1 to 10, where 10 being the most important thread, like a highly prioritized thread. It will be, preempting all other threads when it comes into action. Now I have again added before, since all the execution is all ready, right? Doesn't depend on any resources. It just has to print. The thread is currently ready to work, and as it was ready, it worked. So you can see before we call the sleep, the current state is runnable, and the multiplication counter something it has to print. It did its work in some way, we can say. Now another work is current thread after sleep call. Even it went into sleep, but it is still ready to execute. It's just waiting for the sleep to complete. So we are not observing any blocked or waiting state. Okay. Now moving ahead, this is all the housekeeping stuff. Once all the execution is done, multiplication counter finished, this should be printed. So everywhere you can see all the way from 0 to 5 or 0 to 4 as we did, it came to multiplication counter finished, because this particular thread, that completed its work and later on printed its own system logger that was for multiplication counter finished. After execution thread state, which I have added over here, after everything gets done, it's just resting for program to get terminated, because nothing remains in the code itself. So I've again tried to gather the state of the multiplication thread, and here we can see when the thread is into the terminated state. So in the example, like in the presentation also I have written, when a thread has finished its task, it gets into the terminated state. Now thread state after the call to start method, again, like it's just housekeeping stuff that I added. You can remove this and get free from it. And this is how like join helps, and these are some very basic metadata associated to a thread, which you can maybe make a use of to understand what a thread is currently into and what are its metadata altogether. I think we can move ahead with the next part, and that is runnable or thread. So there are two ways of creating a thread. First, we have always understood from the examples that we can extend thread class. We did it in this multiplication thread class. Then in the previous examples, like in increase counter also, we extended the thread class. There is yet another way of extending, of like creating the thread class, is by implementing the runnable interface. For that particular example, I've created another set of classes, that is character gen demo and random character generator. Now in random character generator, I have created the class by implementing runnable interface. As we implement runnable, we have to implement like override two of its methods, that is run, which does the actual work, where it doesn't do anything much in the example, because we are just randomly printing some characters from alphabets, and we have also created its start method. Now if we move ahead and go to character gen demo, it's just a 2-line code basically. Random character generator, new instance, and I've called the start method. And within the start method, I have created like called run. So eventually the control comes to this particular point. And if I execute this, like it will just just work the same way. But there are two ways that I wanted to take you through. First is extending the thread class like how we did over here, and override its run method. And another way is implementing the runnable interface and overriding its or implementing its run and start methods. So which approach is better? If we extend thread class, we cannot extend any other class. So it might not work for us if the class is like mainly extending a class already in a inheritance hierarchy. So we run out of this option, and the one which I personally prefer is implementing the runnable interface, because in the runnable interface, Java can implement as many interface as it wants. So implementing yet another interface that is runnable won't make any harm to the software logic. However, we when we extend the thread, we might run out of the inheritance of one class only in Java quota. So the second one should be the better and the preferred one. However, in this program or this set of examples, to keep things simple, I have just uh, extended thread class itself. So we'll proceed to our understanding with these particular set of examples only. Now moving ahead, there is yet another topic that I wanted to cover with this session is worker threads, or some way we can say the daemon threads. The term is interchangeably used, the worker threads or the daemon threads. So as the Java program starts, one thing is for sure starting, that is the main thread, which starts the main method. So here we saw, right, whenever we were starting or we were understanding the statuses of the thread, main was yet another a thread. Okay, so we can create many child threads inside main thread. So eventually when the main thread started, all the threads started following it. So this is more understood over that particular, the first example that we had, counter demo thread. So main was something which started, and then other threads got created within it. Other way we can say that all the threads were part of the thread group main, so that is also something worth noticing. The main thread is last to execute because it does perform various shutdown operation, so due to its by default switching on and turning off nature. The daemon threads are very low priority threads. They can be just running in the background, pretty much helping sometimes the JVM for housekeeping stuff such as garbage collection. Now these particular threads, although they are very lightweight, low priority, they are terminated by the JVM. Okay, as all the other threads terminate. Don't have to, add any condition for them to terminate manually. They get terminated whenever all the threads are done with their work. One of the example that I can call out is the in a phone apps, maybe a thread or a simple process might be looking around for Bluetooth devices without affecting the performance of your particular application. They are just doing their work in the background, maybe looking for network services, all sort of that work. So here we will understand the daemon threads with the practical set of examples, and this will be something very interesting here. Now in the daemon thread, this is a class that I have created by using extends thread. In the run method, I have created an infinite loop by creating a condition while true, and this just sleeps for 1 second, and after 1 second it comes into action and prints daemon thread is running. That's it. We don't want it to do anything else. It's already a low priority thread. Now in the class daemon demo, I have created the main thread started and everything I've done just for tracking the logs, how the system is working. And I've created an instance of daemon thread by just as if we will create any other instance. And there is yet another example of thread, like simple printing thread that I've created. Quickly want you to see what this thread is all about. It just prints the number. Again, it's just more like increase counter, but something different for the name for to avoid confusions. So once this is done, it prints simple printing thread is done and all the numbers that it counts, whatever. Now coming back to this particular main code, daemon thread, we have used the method set daemon and made it true. So when we describe this, it gives the property to the thread that this particular thread is daemon thread. It will be a low priority thread, it will run in background, and it will be terminated as all the other threads are done with their work. Also we have created we have called the start method for both of them, since uh, both of them are threads, so start method has to be called for them to get into action. But we will observe daemon thread will keep on working until simple printing thread has completed its work. So let's hop over and run this code. Already been through like why the main things got printed first and finished, but here you can see that simple printing thread, it's doing its work, but the daemon thread is also intercepting and taking the show in the console, and it's just doing its work. We can even extend our counts to maybe 10 for understanding this. You run the program yet again, and I'll just expand this. So although the thread is running, the main thread, the simple printing thread is running, the daemon thread is also running in the background and doing its own work. And it got terminated as it was done. Daemon thread did execute because it might have got the chance to execute. And until then the simple thread might be running. The output could be different every time you execute, and also depends on your machine architecture. So mine is Apple at the moment, so it's this that we have here. So simple printing thread is done, and you can observe, right, the daemon thread is also done with its work, although we had given it an infinite loop condition. So this is somewhat like you can understand for the daemon threads to begin with. Now we are here at the priorities of the thread. When we talk of thread priority, if there are two threads that have the same priority, the first come first serve is adapted. The thread scheduler essentially queues them. Okay, now 1 is the min priority and 10 is the max priority. So these are basically the constants also that are defined in Java itself. By the value that they have is 1 to 10, so you can put the priority of a thread within this particular range. A higher priority thread is executed before the lower priority thread, but it still again depends on the host operating systems, and here the operating systems are smart enough to avoid the thread starvation nowadays. So the output might be different for each and every case, but the priority that we set is is mainly setting something for the JVM to understand which to execute when, and which thread should be preempting an execution of the current thread. So again I'll hop over to thread states, and I'll set the priority of this particular thread, okay, to 10, and we'll just understand the code. So the priority, and earlier it was 5, if you can pause or reverse the video. When we executed this initially, when this was commented, the priority by default was 5, but now if we have set it to 10, it became the highest priority thread. In upcoming examples further in the sessions, we will deal more with the priority things of the thread. So I will explain you like how a priority particularly contributes to preemption and which thread should be executed. It helps the JVM to pick up the task and execute with the decision. So yeah, that's particularly that's all of it for understanding and onboarding into threads, right? So thank you for watching everyone, and I hope it did help you to onboard with the thread, and all the best for the learning threads ahead. Thank you.